What is up, YouTube? Let's learn about what input validation is and how it can be used to secure our APIs. Let's get into it. So, to introduce this, input validation is the process of validating the data being processed by our API against a defined standard. It's essential to examine whether the data inputted into our API is correct and consistent. Our API could break due to the lack of scrutiny. APIs are our first line of defense against potentially problematic input data. User inputs in general should be considered untrustworthy and have to be verified. So, several attacks are dependent on the inputs not being validated, which lets attackers manipulate backend code. There are two types of input validations, being client validation and server validation. Before we learn about these validation techniques, let's define the threats we aim to defend our APIs against. Some common API attacks, which you can look into on your own time, are code injection, there's cross site scripting, there's SQL injection, there's carriage return line feed injection, and buffer overflow. These attacks manipulate APIs by executing malicious code inside the system. By injecting unverified inputs into our systems, an API with insufficient input validation may fall victim to such attacks. The effects of these attacks are similar and include denial of service, information disclosure, financial and reputation loss, phishing, data alteration, and so on. We'll explore client and server side input validation and learn how it aids in preventing various attacks mentioned. So, firstly, let's talk about client side validation. Data inputted through the client side can never be trusted, and a careless user is much more common than a malicious one. Therefore, client side validation is implemented in the browser. To combat errors, a response is instantly fed back to the user in real time, commonly by highlighting the error and displaying the subsequent message. So, in this first example for name, you can see the text box is in red and you have a hint saying that name is a required field. So it gives you a message, and this is usually implemented through a client-side scripting language such as JavaScript. If an email or password is inputted in an incorrect format, an email without an @ sign, for example, it wouldn't pass the validation check. So the following code snippet illustrates a primitive example of how the validation on the email field above may be performed. Client-side validation not only bolsters security, but also lightens the load on the server because it prevents incorrect data from reaching the server through communication channels. So here we have a email validation function, and it looks at the form values for email, and it checks if it's empty, then it'll give you an alert and it'll return false, right? The server performs its own checks on the data it receives, which is good practice to have both validation schemes working together. All input validation is implemented primarily in the user's browser, which is not completely secure as the attacker can bypass our scripting language and forward dangerous input to the server. And so for that, we need another layer of input validation, which is known as server-side validation. So how can an attacker bypass client-side input validation? Client-side validation isn't foolproof because an attacker can easily modify the client-side code through developer tools. Implementing validation solely on the client side is not advisable, and it's the same when an OS verifies the arguments of a system call before acting on it, even though it was validated probably by the language runtime before calling the system call. Now let's talk about server-side validation. The server side performs additional checks on the inputs cleared by the client. Typically, a combination of checks are utilized to verify this data, some of which are stated in the table. So firstly, we have a format check, which checks whether the values are in the correct format, a length check, which checks whether the values are of the correct length, a presence check, which checks whether the required data has been entered, a range check, which checks whether the data inputted are in the range specified, a lookup table, which looks whether the entered data is among those in our input table, remove harmful characters, checks whether any harmful characters used in injection attacks are entered, and removes them. The most popular example of this is when websites ask us to create a strong password. This validates whether the input is of the correct size, is alphanumeric, and in some cases requires special characters. The password entered by the user is validated on the server, and a response is given to the user corresponding to whether the rules defined were met. And it's best to be redundant and check inputs validated by the client already on the server. Since it's the last line of defense, we just want to double check and make sure. So let's do a quick quiz. Why is client-side validation required when we already utilize server-side validation? Client-side validation is needed to reduce user latency because they'll get an instant response if incorrect values are entered, which leads to a better user experience. And client-side validation is also needed to reduce the strain on the server because it can reject incorrect data it detects without the need for it to be sent to the server. If we have to perform input validation on only one side, which is the preferred side? Well, the server side is the preferred side because it's impossible for malicious users to alter it so easily, like we can do on the client side. Thanks so much for watching, and I know it's a pretty obvious topic and it's pretty simple to people that already work on APIs, but I thought it needed to be mentioned since it's common practice. And if you enjoyed the video, leave a like and subscribe. If you have any questions, leave a comment, and I'll see you in the next one.